Hello Matinix! I hope by this time you have already watched the video regarding our subject orientation in pre-calculus, wherein I have given you the scope and also the subtopics and the requirements, and you are also informed about how your grades will be computed. This moment or one of the things that I have told you on that video is that pre-calculus is an application of what you have learned in the junior high school, and it is also a connection and preparation to your future mathematics courses or subjects. And one of those applications or concepts that I am assuming that you have already mastered when you were in grade 10 is factoring, because this is a very essential topic to pre-calculus, because every now and then you're going to factor algebraic expressions. Okay, so this time I am going to review you on this factoring concept or subject matter. Okay, and I am also hoping that at least one of your teachers in mathematics when you were in junior high school presented you this factoring flowchart. Okay, so this is our factoring flowchart. It is a guide on how we are going to factor different types of algebraic expressions. Okay, so the first question that you should be asking when you are dealing with factoring is, does a greatest common factor exist? Okay, or that is, do we have a GCF? Okay, so if the answer is yes, then here is the next step. Factor out the greatest common factor, and after that you proceed to that. Okay, and if the answer is no, you're just going to follow the arrow. Okay, so does it have only two terms? Is it a binomial? If the answer is yes, then the next question is the difference of two squares, or is it a difference of two squares? If the answer is yes, then use this, a squared minus b squared. I know you have already or you are already familiar with this. Okay, it is called the difference of two squares. The first term should be a perfect square, the second term should be a perfect square, and the operation is a subtraction. Okay, and so the factors are a minus b times a plus b. But if it is not a difference of two squares, then the next question is it the sum or difference of two cubes? Then if the answer is yes, then you are going to consider this, okay, or apply this. Then if the answer is no, then it is already a prime factor or a prime number or a prime algebraic expression. Okay, so along the way we're going to touch all these steps as we're going to solve here 10. We're going to factor 10 algebraic expressions here, one after the other. Okay, so number one, we have here x squared plus 3x plus 2. Now for the first question, does it have a greatest common factor, or does a greatest common factor exist? Of course, there is no common factor among these three terms. Okay, so the next question or the next step is, does it have only two terms? How many terms do we have? We have 1, 2, 3. Okay, so the answer is no. So the next question will be, does it have only 3 terms? Do we have 3 terms? Yes. Then the next question is it a perfect square trinomial? How do you identify a perfect square trinomial? It is in the form x squared plus bx plus Oh, sorry. It should be, ay, andun pala. Okay, it is in the form, here it is. Where is my camera? Okay, here it is. Okay, it is in the form a squared plus 2ab plus b squared. So it will be, or it can be factored as a plus b quantity squared. Okay, but this time the most or the shortcut in identifying whether it is a perfect square trinomial is if the first term is a perfect square, the second term is a perfect square, and the middle term is the product of the first and the second multiplied by 2. Okay, but this time 2 is not a perfect square. Our last term is not a perfect square, therefore it is definitely not a perfect square. Okay, so no. Then, is it a general trinomial? Is it a general trinomial? Okay, we will see. How are we going to identify whether it is a general trinomial? Okay, let us follow these steps. Okay, let us see. The first step is to get the factor of the last term. What are the factors of 2? Okay, since we have here plus and plus, remember, if these are addition and addition, the factors are both positive. Let me repeat that. If these are plus and plus, then the factors are both positive. So what are the positive factors of 2? We have 2 and 1, both positive, positive 2 and positive 1. After getting all the possible factors, we are going to add these factors. So 2 times 1 is 3. Okay, and you should find the factors whose sum is equal to b, or the coefficient of the middle term. What is our coefficient of the middle term? It is positive 3. Therefore, 2 and 1 are the factors that we are looking for. Okay, therefore we can now write the factors of x squared plus 3x plus 2 as x plus 2, positive 2, and x plus 1, positive 1. Okay, as easy as that. Okay, next we have x minus 12. Okay, x squared minus x minus 2 rather. Sorry. Okay, so again, we do not have a GCF. We have 3 terms, and definitely we do not have a perfect square trinomial. Okay, so again, we are going to look for the factors of this. Okay, so since we have a negative c, or negative value of c, and this is minus and minus, listen to this. If these are minus and minus, then one of our factors is positive and the other is negative. But since this is minus, then our greater number, or our greater factor should be negative. Okay, so look at this. If we have here negative 2 and positive 1, and we also have negative 1 and positive 2, and we are going to add these 2 factors, here we will get negative 1, and here we will get positive 1. But then our middle term, or the coefficient of our middle term, is negative 1. Therefore, these are the factors we are looking for. Okay, so we can now write our factors as x minus 2 and x plus 1. As simple as that. Okay, now let us proceed to our third example. We have 2a squared plus 6a plus 4. Now, the first question, what is the first question? It is, does a greatest common factor exist? Do we have a common factor? Yes, we do. Okay, we do have. Okay, 2 as our greatest common factor. Now, we should get the quotient as our, this is already one of our factors, and the quotient is one of the other, or it is the other factor. Okay, so we're going to divide each term by our GCF. So 2a squared divided by 2 is a squared, plus 6a divided by 2 is 3a, plus 4 divided by 2 is 2. Okay, so it seems like our factors are 2, so we are going to write our factors this way: 2 and a squared plus 3a plus 2. Okay, but we are not yet done. Okay, so because our quotient is still factorable. Okay, and it is the same with our number 1. Okay, they just have different variables. Okay, we just use different variables. Therefore, we are going to get the factors of this. So since it is plus and that is also plus, then both of our factors are positive, and if we are going to add those, it will be equal to our middle term, okay, or the coefficient of our middle term. So the factors of our quotient are a plus 2 and a plus 1, but do not forget we have there our GCF, which is also one of our factors. So these are the factors of 2a squared plus 6a plus 4. Okay, next we have number 4. This time, do we have a common factor? Oh, sorry, clerical error. This should be m. Okay, sorry guys, that should be m. So we have here 7n squared minus 14n minus 21. Okay, this time, do we have a greatest common factor? Yes, we do. So our greatest common factor is equal to 7. So again, we're going to find the quotient as it is one of the factors. So 7n squared divided by 7 is n squared, minus 14n divided by 7 is 2n, minus 21 divided by 7 is 3. So this is our quotient. So we're going to write our factors are 7, our greatest common factor, times the quotient, n squared minus 2n minus 3. Okay, but then again, we are not yet done since our quotient is still factorable. Okay, so what are the factors of negative 3? So again, this is negative and negative, or minus and minus rather. So one of the factors are or is negative, and it is the greatest factor since this is negative. Okay, so we have negative 3 and 1. Okay, because if you're going to add that is equal to negative 2. So we have the factors, our greatest common factor, n minus 3 times n plus 1. Okay, as easy as that. Then let us proceed to number 4. We have, or number 5 rather. We have a cubed minus 5a squared plus 4a. Do we have a GCF? Yes, and it is a. So our quotient is a cubed divided by a is a squared, minus 5a squared divided by a is 5a, plus 4a divided by a is 4. Okay, so again, this is a trinomial. Do we have a perfect square trinomial? Do you think so? Because a squared is a perfect square and 4 is a perfect square. But then, if you're going to multiply 4 times a, or 4 times a times 2, that will be equal to 8, and that is not equal to 5. Therefore, it is not a perfect square. So, still we have to look for the factors of positive 4. Okay, this time, since this is minus and this is plus, listen, if this is minus and this is plus, then both of our factors are negative. So what are the negative factors of 4? Negative 2 and negative 2. Because negative 2 times negative 2 is positive 4. Okay, we also have negative 1, negative 4 and negative 1. Okay, that is if and only if this is minus and that is plus. Okay, so if we're going to add these factors, then we will get negative 4 and negative 5. So which of this is equal to the coefficient of the middle term? Okay, so it is negative 4 and negative 1. Therefore, we're going to write our factors as A, our GCF, times A minus 4 and A minus 1. Okay, it is very simple.